In this example, we want to state the domain and range of the function graphed below. Our function is comprised of two sections. We have the red line on the left and the blue line on the right. So taking into account both of these pieces together are the one function. We want to talk about the domain and range. So let's start with talking about the domain. So when we talk about domain, remember that we're trying to describe all possible inputs, which typically means we are trying to describe the x values. I always like to go left to right, especially because we typically use interval notation. So going from smallest to greatest is how we do that. So on the very far left, the farthest point that I have is that green solid point there. So if I look at my x-axis and I consider the scale here, so if this is 5, 1, 2, 3, 4, 5, so this is counting by ones. So the farthest left x value that's being used is 1. And because the dot is solid, I am allowed to use that value. So I would start with a square bracket, positive 1. As I start looking across my function, so imagine putting yourself on the x-axis and you start walking from that point. I see the red line goes all the way up to 5, where that open circle is. And then I have a bit of a jump from that point to where the next section starts. So for my domain, I can go from positive 1 included up until positive 5, but the positive 5 is not included because it's an open circle. So I have to use a curved parenthesis there. I jump across, and now I'm underneath the black dot here. So looking where we are on the x-axis, that would be at 7. So my domain picks up at 7, so I'm going to use my union symbol, and that is a filled in circle. So I have a square bracket, 7, comma, and I keep walking, and I stop on the x-axis at 10, and I have an open circle there. So 10 is not included, so I would have 10 with a curved parenthesis. That describes all possible inputs or x values that are being used here, so that is the domain of our function. So now we want to talk about the range. So instead of thinking horizontally, we now want to think vertically. So now we're looking at all possible outputs, which typically are going to be our y values. So we're going to go through a very similar process that we did for the domain. We're just switching where we're looking. So let's start fresh here. And again, because we want to describe an interval, let's figure out what's the smallest y value that's being used, and then we'll build from there. So the lowest point I can find vertically is here. So on our y-axis, if this is 5, 1, 2, 3, 4, 5, so 1, 2, 3. So the lowest y value that's being used is positive 3, and it is a solid point, so our range is going to start at positive 3. So imagine that you're climbing up the y-axis. I see the red section all the way until I hit that open circle. So looking on our y-axis, 5, 6, 7. So the y value of 7 is not included there. However, when I look at the other section, I do have a closed circle at 7. So the 7 actually is included. So again, we're looking vertically here. So we actually don't have a jump happening because we go all the way up to 7 and then the second piece starts at 7. So everything so far is still covered. So then I keep going up the y-axis and I'm looking at the blue, and I go all the way up until a y value of 10. And that is open, so that's not included. So we would have 10 with a curved parenthesis. And that fully describes all of the y values that are being used. So that would be our range of our function. Again, there's no jump when we're looking vertically because the open circle at 5, 7 and the closed circle at 7, 7, there is no jump there vertically. I know there's a jump horizontally, and we saw that in our domain, but there is no jump vertically. So our range is being able to be described as one interval from 3 included to 10 not included.